through these examples. Go through all of them. So obviously it's requiring us to be better at our exact triangles than I am at holding onto a pen. We need to make sure that with this it's all about rearranging and then identifying with our car circle and our exact triangles. So these could all be asked on a tech-free exam. Obviously if it was tech active you could just shove it into your calculator. But on a tech-free exam we need to go through a pretty steady process to identify the number of solutions, and for most of these we would expect to see how many solutions. How many would we expect to see? 2 solutions for most of these. We must check our domain. The domain tells us 2 things. Number 1, what values we're looking for, and number 2, whether we're dealing with radians or degrees. So straight up we can see that we're dealing with radians. From there I just rearrange. So if I'm looking at this first one, the first thing I do is divide both sides by 2. I'm left with sine x equals root 3 on 2. What I'm really doing there is, if I was doing it in my calculator, saying x equals sine negative 1 root 3 on 2. And rather than using my calculator at this point, I would use my exact triangles. I identify that I have my triangle with root 3 and 2 in it. From here, I look for the angle, because what is sine equal? Sine is equal to opposite over hypotenuse, so I need to look for the angle that gives me root 3 as my opposite. What angle allows me to have root 3 as my opposite? Pi on 3, which means that I'm dealing with that as my key angle. Am I positive or negative? In this example, is my value positive or negative? Positive. So what quadrants am I in? The first and the second. So I already know one angle is equal to pi on 3. I now need my second angle, which occurs in my second quadrant, where this equals pi on 3. But I can't just say we're pi on 3 pi on 3 clockwise from the halfway line, can I? I need to represent that as an angle from where? From this point here, correct? So what is this angle? Well, what do I know about my car circle? I know that this point here represents pi. And I know that I'm pi on 3 back from pi, correct? So I can represent that, x1 is equal to pi on 3, x2 is equal to pi, take pi on 3, which gives me 2 pi on 3. There are no other solutions in that domain, so my problem is done. Clear? Who felt pretty comfortable with that? If you didn't feel comfortable with that, you need to review your car circles and your exact triangles. We should all be at that stage. If we're not, that's fine, we've got time to remedy that. Question 2, we apply the same process. First step is rearranging. So I'm dividing both sides by negative 2. I'm now left with cos x, or really, I don't need that. X equals cos negative 1, 1 on negative 2. Now at this point in time, do I do something a bit different? What do I do here? I don't like dealing with that negative, do I? So I'm just going to introduce a term xk. What does xk stand for? My key angle. And I'm just going to treat it as though it's positive. I then go to my, at this point here, what can I do? Where should I be thinking? Exact triangles. I need an angle that gives me an adjacent of 1. Which angle is that? Pi on 3. So I know that my key angle, xk, is equal to pi on 3. Now, was my original value positive or negative? Negative. So I say, well, where is cos negative? What quadrants is cos negative? And they are quadrant 2 and quadrant 3. So I redraw my little diagram. And I've got a value there and a value there, correct? The key angle is? What's my key angle? Pi on 3. my first value, x1, is going to equal? Jared? It would be, which would give me 2 pi on 3. And my second value, x2, will be pi plus pi on 3, which equals 4 pi on 3. Sweet. What do we notice about that? Was the process pretty similar between one A and B? Or was different? Did I introduce a key angle in one? Or not? I didn't need to. Why did I not need to? My original value was positive. In question 2, I did introduce a key angle. Yep. Why is it in the second quadrant? Because what are we dealing with here? What's the trig identity? Sine, cos, or tan? So where is cos negative? Second and third quadrants. That's why it's in the second quadrant. Yeah. If it was positive, it would be in the first and the fourth. Now, if we look at question 3, it's a little bit different. Why is it different? C. If we look at question C, why is it different? Tell me something that you notice is different about this problem between this and the first two. We have a phase shift, very good. We have a translation in there. So we need to account for that. But the process is still much the same. We follow our rearranging techniques. I'm just going to remove a bit of the noise on the board. So in this question here, I do the same thing with my rearranging. What should I get rid of first? The pi on 4 or the tan? Tan. So I get rid of the tan first, and I've got x minus pi on 4. I'm going to put x1 equals tan negative 1 root 3. I draw my exact triangle again. Root 3, 2, and 1. What does tan equal? Opposite over, other way around with my angles. Opposite over adjacent, correct? So which angle gives me an opposite of root 3 and an adjacent of 1? Pi on 3. So I know that x1 minus pi on 4 equals pi on 3. Where else does this occur? Is that the only place that tan equals root 3? Where else? I draw my circle. I know that it occurs there. Where else does it occur? Which quadrant? Quadrant? Quadrant 3. So if x1 equals pi on 3, what's x2 going to equal? Pi t. That's pi, isn't it? That'll be pi on 3. So x2 will equal, x2 minus pi on 4 will equal 4 pi on 3. Just going to get rid of my exact car circle. That's gross. What do I do from here? Rearrange by adding pi on 4 to both sides. Remember in year 10 when I said you need to learn to love fractions? Wasn't lying. x1 equals pi on 3 plus pi on 4. x2 equals 4 pi on 3 plus pi on 4. We cross multiply. x1 equals 7 pi on 12. x2 equals 19 pi on 12. And there are two solutions. Are they within our domain? Are they not? They are within our domain. Up to 24 pi on 12 would be within our domain. For question D, I'm not going to solve it for you. I want you to have a little bit of a think, but how many solutions would you expect to get for question D? How many? 4. Because it is 2 inside our brackets, we when we divide by 2, because when we rearrange that, we're going to divide our values by 2, which means that we're going to get 2 rotations worth of our domain. Does that make sense? Have a go at that. There's obviously heaps of revisions to get through.